Hello, SCADA services are widely used in power systems. What are they? A V.24 service serves as a good example. To explain how SCADA is carried over SRv6 tunnels, a supervisory control and data acquisition system, SCADA for short, is a distributed computer system that's used for automatic electrical power monitoring. It monitors and controls the running status of a power grid in real time, providing a series of functions through advanced power grid application software. These functions include power grid operation dispatch, control and monitoring, power flow analysis, stability analysis, and state estimation. So, SCADA is indispensable for power grid dispatch automation. A SCADA system is composed of remote servers, a communication system, power station remote terminal units, RTUs for short, and a console terminal. The master station processes the monitoring data of power stations for automated dispatch and control. There are many different standard communication interfaces, including RS-232, RS-485, V.24, and X21, involved in a SCADA system. We will use V.24 as an example to introduce how to test a V.24 service over SRv6 policy. V.24 is an interface standard defined by ITU-T and specified for the one physical layer. V.24 cable interfaces are available on both the data circuit terminating equipment and data terminal equipment sites, referred to as DCE and DTE, corresponding to the network side and user side, respectively. The DCE side is a 25-hole circuit and the DTE side is a 25-pin plug. Huawei provides an 8-channel V.35, X21, and V.24 board. The related interface standard is DB28. For the V.24 cable, one end is DB25, DCE or DTE, and the other is DB28. Generally, a net engine router functions as a DCE device and the connected terminal functions as a DTE device. Correspondingly, the DTE cable is connected to the terminal and the DCE cable is connected to the device interface card. We need to connect the DB25 female connector of the DCE cable to the male connector of the DTE cable. Here, you can see some key configurations for the V.24 interface. Set the port's working mode to V.24. Then, select the synchronous or asynchronous physical mode. Enable the TDM link protocol. Bind the PWE3 service with an SRv6 policy. You can see here the basic test topology and the test procedure. In a lab, we use a tester to simulate an RTU because a tester supports only one V.24 interface at a time. We need to perform physical loopback on the remote end. Now, let's see how to test the V.24 service over SRv6 in a lab environment according to the test procedure. First, deploy FlexE network slicing and create 3 slices for all devices. Slice 0 is the default slice, and slice 1 and 2 are service slices. Configure IPv4 and IPv6 addresses on the base slice interface. There is no need to configure IP addresses on other slice interface. Deploy SS to ensure root reachability on the entire network. Check IPv4 and IPv6 routing information on the device. Activate MPLS L2 VPN on duty 1 and duty 2. An LDP session is set up between the two devices. The session status is up. Activate SRv6. Configure locator information. Define segment list to work as primary and backup paths. Create an SRv6 terminal and recurse the terminal to network slice 1. Check the SRv6 policy status on duty 1. The primary and backup paths of the terminal are up and bound to network slice 1. SBFD is used to quickly detect path faults. Hot backup is used to quickly switch traffic to the backup path if the primary path fails. The same results are displayed on duty 2. Now, enter the V.24 interface view. Configure the port mode as V.24. The interface can work in DTE or DCE mode. Generally, the default DCE mode is used and the connected terminal is DTE. Configure the physical mode as required. The default mode is asynchronous. You can also run the related command to change the mode to synchronous. For the synchronous V.24 service, the fixed baud rate is 64 kbps per second. After the TDM link protocol is activated, deploy end-to-end PWE3 service and bind them to the created SRv6 policy using the color value. Check the static PWE3 status on duty 1 and duty 2. The PW state is up. On the Xgenius tester, set the V.24 service parameters to work in synchronous mode. Check the service running status. We can see the lights are all green and the tester can calculate the round-trip delay. This indicates that the service is running normally. For the V.24 service in asynchronous mode, ensure that the serial port parameters are consistent with those of the connected terminal. For example, the default baud rate is 9600 bps, stop bit is 1, data bit is 8, and the party check is not performed. Ensure that the attributes of the local and remote interfaces are consistent. Now, enable the TDM link protocol and deploy an end-to-end PWE3 service. Bind the service to the SRv6 policy. Check the static PWE3 status on duty 1 and duty 2. The PW state is ARP. Change the tester to work in V.24 asynchronous mode and set the parameters so that they are the same as those of the device interface. Run the test. The tester successfully sends service traffic and calculates the round-trip delay. That's all for this video about the V.24 service over SRv6. Thank you for watching.